Hello, ladies and gentlemen. I'm going to take up a solution for question 9, section 2.5. This is the section about solving probability problems using permutations. So let's see now. Before I begin, I'm just going to talk about the question here. A four-letter word jumble is being formed from the letters in the word logarithm. This is classic. You can expect some sort of question that relates to using letters from a word like this. So there are how many letters in this word? 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. And in part A, we're asked what's the probability that spells math. Well, first of all, I'm going to consider the universal set. So the number of ways that you can choose any 4 letters from 9. I guess I'll call that the universal set, or the sample space, which is going to be 9p4, and when you calculate 9p4, I think it comes out to 3024. So now part A, we'll use that. We're going to basically say we want the probability that we can spell the word math, so the probability that we spell math exactly in that order, which is out of 9p4, out of all the things that could be spelled, there's exactly one of them that spells math. There's only one letter M, only one letter A, only one letter T, only one letter H. So one way out of 9p4, or 1 out of 3024. Part B says what's the probability that it includes the letters M, A, T, and H, but not necessarily spelling the word math. Maybe, I don't know, ATHM or TAMH or something like that. So that's very similar. I'm just going to depict this case by saying M, A, T, H, kind of like how they do here. And so how many ways can that happen? Well, I guess if we're working, we know we're working with the letters M, A, T, and H, but we don't necessarily know that it's in that order, right? Or else it would be case A. So there are 4 factorial ways to arrange those 4 letters. So we know that's how many different ways it could happen. And of course it's out of 9p4. That works out to be 24. 4 factorial is 24 out of 3024. So I think that reduces to 1 over 126. Let me just check that. Yep, that's right, 1 over 126. By the way, I encounter students all the time that don't know they have a fraction button on the calculator. If you enter that on your calculator, it'll reduce it for you. Good idea, especially in a course like this. If you don't know how to do that, ask your friend or ask me, and I'll show you how to use the fraction button. I mean, there's nothing wrong with doing it the old school way. If you happen to notice that 24 divides into 3024, then it's easy, but sometimes it doesn't reduce quite that easily. So, let's see now. Part C says, what's the probability that includes the letter M? So the probability that we have for letter M, and of course, the M could be anywhere. In fact, I'm going to go ahead and say there are 4 places where I could place the M. And then there's 3 remaining letters. So from the 3 remaining letters, I can choose any of these 9, just not the M. So that, sorry, not 9, but any of the 8, if I don't include the M. So that would be 8p3 ways to order the remaining 3 digits. And of course that's still going to be out of the 9p4 ways that I could pick any 4 letters. So 4 times 8p3 comes out to 1,344. You can check my math. And 9p4 is still 3,024. So what does that reduce to? So that reduces to 4 over 9. Okay, I hope that helps. Like I said, it's a classic question. You can probably expect to see something like that on your test. And certainly in the chapters to come, we're going to be doing more work with classic questions like this with further restrictions and refinements. Hope this helps. Talk to you later.